Hey everyone, today we're going to go on this pretty incredible journey, one that you actually take every single time you go online. We're going to follow a single web request all the way from your keyboard to a server, maybe halfway across the world, and all the way back again. You know, it feels totally instant, right? You click a link and boom, the page just appears. But behind that one simple click, there's this incredibly complex, high-speed chain of events that literally circles the globe. It's like a silent conversation between machines, and it all happens in just milliseconds. Okay, let's dive right in, starting with the very first thing that happens. And you know, surprisingly, it's not you typing in a web address. It actually happens the second you connect to a network. So before you do anything else, the moment you hop on Wi-Fi or plug in that Ethernet cable, your device automatically gets a temporary IP address. A system called DHCP handles this. Think of it like being handed a numbered jersey the second you join the team. You need it to play. Then, when you type in that web address and hit enter, your browser sends out its message. This is called an HTTP request, and it's basically the starting pistol for this high-speed race across the internet. But here's the thing, there's a little problem. Your computer, well, it doesn't really understand website names. It speaks a totally different language, a language of numbers. See, we use what are called host names, www.explainer.com, because they're easy for us humans to remember. Computers, on the other hand, they need these super specific numerical IP addresses to find anything. It's kind of the difference between knowing a friend's name and knowing their exact street address, house number, and all. So how in the world does your browser translate that name into an address? Well, it uses this brilliant service called the Domain Name System, or DNS for short. You can think of it as the internet's universal translator, and it's the very first stop on a request's big journey. The best analogy is to think of DNS as a massive, super fast phone book for the entire internet. Your browser sends the website name to a DNS server, which looks it up and instantly finds the correct IP address, the right number for your computer to connect to. All right, so now your computer has the correct address, but it still needs to figure out the rules for talking to the website server. I mean, you can't just start yelling data across the web. There has to be some kind of order, right? And these rules, they're called protocols. They're basically the agreed-upon language and etiquette for the entire internet. They make sure that every single device, doesn't matter who made it or where it is, can communicate with every other device. Now, at the very heart of all this are two main protocols, TCP and IP. You should think of them as the power couple of the internet. IP is in charge of the addressing, making sure data gets to the right place, while TCP manages the conversation itself, making sure it's reliable and everything arrives in order. They work together just perfectly. So what does that really mean? Well, TCP is like the conversation manager. It makes absolutely sure that all the data arrives safely with no errors and that it all gets put back together in the correct order. It's the reason you see a nice clean web page instead of a jumbled mess of code and images. This analogy just nails it. The IP protocol is like your standard postal worker. Their job is to get the mail to the right address. Simple as that. But the TCP protocol, that's like certified mail. It doesn't just deliver, it checks to make sure the message arrives safely, that it was signed for, and that nothing got lost on the way. Okay, so we've got the address, and we've got the rules of conversation. But how does the data itself actually get sent? I mean, you can't just send an entire web page through the digital pipes all at once. Yeah, imagine trying to shove an entire encyclopedia through a tiny mail slot. It's just not going to work, right? Sending a whole website in one go would be just as clumsy. So instead, the internet uses this really clever system called packet switching. It's what makes the internet so incredibly scalable and tough. So here's how it works. TCP takes all the data for that web page and just slices it up into all these smaller chunks. Then the IP protocol takes each of those chunks and wraps them in a little digital envelope, creating what we call packets. Each one is now ready to make its own journey across the internet. And every single one of these packets is like a tiny digital postcard. It's got a small piece of the message, a to address, a from address, and, crucially, a sequence number. That number tells the computer on the other end how to put the whole message back together correctly. So our message has been transformed into this collection of maybe thousands of tiny digital postcards. Now they're ready to be sent out across the entire global network. Now, these packets don't just wander around hoping to find their way. They're guided by these specialized computers called routers. A router's job is basically to act like a traffic cop for the internet.
It reads the destination address on each packet and points it in the right direction, along the fastest, most efficient path.
And here's something that just kind of blows my mind. Packets from the very same web page can take completely different paths across the world to get to you. One might zip through London, another might go through Tokyo. This is what makes the internet so resilient. If one path gets blocked or slows down, the packets just get rerouted on the fly.
Okay, the journey is almost over. After traveling across continents and under oceans, all in a fraction of a second, the packets have finally reached their destination, your computer. So now, your browser becomes the final assembly station. It's getting the stream of packets. And because they all took different routes, they're probably all out of order. But remember those sequence numbers? TCP uses them to put the puzzle back together perfectly, recreating the original web page data exactly as it was sent. Your browser takes that perfectly reassembled data and renders it. It translates all that code into the images, the text, and the interactive stuff that makes up the complete web page you see on your screen. And the most amazing part of all of this, from your first click to that fully loaded page, this entire global journey, the DNS lookup, the TCP handshake, the slicing into packets, the routing across the world, and the final reassembly, all of it usually takes less than a second. It's just an absolutely extraordinary feat of engineering. I mean, this whole network of networks is built on real physical stuff. Undersea cables, peering agreements, data centers, the actual backbone of our digital world. But explaining all of that, well, that sounds like a journey for another time. Thanks for joining me.